Volatility's Python tutorial. This is part 2. Today we're going to be covering using some popular analytics libraries. We'll be focusing primarily on one called Pandas. Pandas is an open source library that provides easy to use data structures and data analysis tools. We'll also be highlighting a little bit of one called Numpy. This is more of a complex mathematical and data structure library. You normally see these two libraries used together, or you'll see them overlap quite a bit. So I just kind of want to introduce the two together. So before we go ahead and get started, just to recap from last lesson, what we did was installed Python, installed Python's package manager, using Python's package manager, installed Jupyter Notebooks, spun up a Jupyter Notebook, wrote some basic code, so defining some variables and writing our first functions, and then learning how to execute and navigate through a Jupyter Notebook. So today we're going to get set up installing Pandas and Numpy. So first things first, let's use Python's package manager to install our dependencies. So I'm going to run pip3 install Pandas, run that, and I'll do the same for Numpy. All right, so I've already got these both installed on my machine. Once these are installed on yours, you should be good to go ahead and spin up a Jupyter Notebook. And again, to do that, what we do is we type Jupyter Notebook, and then you'll have a browser window that opens. All right, so here we can see I have the code from the first lesson around defining variables and functions. I created a new file called Pandas. This is the one that I'll be using to show the examples of Pandas, a little bit of Numpy, and then I'll kind of show using Pandas in a more practical sense outside of some of the basic commands. So I'm going to open up the file that I created. We've got a blank canvas, and so first things first, we've got our libraries installed. We need to tell the Jupyter Notebook to import or bring in all the functions and things that these libraries do. So to do that, what we're going to want to do is import pandas, and then I'm going to type as PD. So this is just a way to kind of shorten or give an alias to the pandas library. So if I type PD, it saves me from having to type pandas all the time. And then in the same cell, I'm going to just import numpy, same thing as NP. And then I hit Control Enter, and these libraries are installed in my notebook, and I can access all their functionality. So the way to think about pandas is to think about it's a two-dimensional. Pandas provides you the access of a data frame, and a data frame is basically a two-dimensional data structure. So think about it like an Excel spreadsheet or a table in SQL if you're familiar with databases. You have rows and you have columns. And so, traditionally we're used to functioning and working with data in that structure, and Pandas gives us a great starting point to do a lot of complex things, and they simplify a lot of the work that could be done manually. So I'm going to go ahead and create a Pandas data frame, and I'll be using a portion of NumPy to do this. So first things first, I'm going to create a variable. I'm going to call it df. Df you'll see reoccurring in a lot of analytics notebooks or code. If you review anything, df is short for data frame. And so I'm going to create a data frame. So to do that, I'm going to type pd data frame, and I'm going to give it values. So I'm going to give it a random, normally distributed group of numbers, and it's going to be 6 by 4. So six rows, 4 columns, and I'm just going to create my column names. I'm just going to give them simple names, A, B, C, and D. All right, so now I've got the code I need to create just a sample data frame. So I'm going to run this. Nothing shows up because I'm just defining a variable for a data frame. So let's just take a look at what the data frame comes out to be. So I've got a bunch of random numbers, 4 columns, 6 rows. And now this is, if you think about yourself working off a spreadsheet, a data frame is essentially a spreadsheet in Python that you can do a lot more you can do a lot more with. So one of the cool things that a Pandas data frame allows you to do is just do some basic like overviews on the data. So you can, if you run .describe off a Pandas data frame, it takes a kind of whole look at the data set and gives you some metrics around it. So it gives you the count of each column, each row, the mean, the min, max, the different percentiles, standard deviations, things like that. You can do a sort on the column. So if I wanted to sort a certain column from high to low, you can do things like sort by, let's go by D. Let's do ascending, false. Oops, sorry, it's sort values. All right, so you can see I've got column D sorted descending. I can flip this to true, so you get the idea. So a Pandas data frame comes with all these things out of the box that are really powerful. We'll go through some more of the things that you can do with a data frame, but let's use it in like a more practical sense. So first things first, you'll notice that I created a random data set that doesn't really have much value to it. There's not a lot of context. And so these are just for the sake of example. So what I've done is, if I jump back here, you'll see I've got a CSV file called ETH OHLC. So I've got a file of the last 100 days of Ethereum open, high, low, close data. So let's use that as a basis for building some basic analysis off spot market data. So first things, I'm going to create a data frame. So I'm going to call it DF. And so one of the cool things that Pandas allows you to do is you can work with data in any format. So I'm going to actually read in some CSV data. And you can do that by typing pd.read_csv, and then the name of the file that's in your folder, ohlc.csv. And I'll explain this part in a second, but what we're going to do is type index call date. All right, so now let's take a look at this data as it came in. So we've got 6 columns, date, currency, open, high, low, close. And we've got about 100 rows worth of data. The index column is basically what's the unique key for each column. So since we're working with daily time series data, I'm going to set the date to be our index. And this is just a special key that allows you to do some things down the road. If you don't define it, I'll show you what that looks like really quick. So it creates an index of just the row number, so just a unique ID. So I'm going to jump back, fix this. All right, cool. So we have some market data in here. And to start, let's just take a look at what this data is telling us. So if we run the describe function on this data set, it can tell us the total record count, the mean for the open, the standard deviation, min, max, the different percentiles. And then you see you get a quick snapshot of everything that your data has. You can do other things like just take a look at the first. You did head 10, you get the first 10 records of the data frame. You could do the same thing if you wanted to look at the last 10. So you could do tail and pull those last 10 out as well. So let's say we want to do some data manipulation to the raw data that we've just consumed. So for example, let's say we just wanted to take the average of the high and the low for the day. So we wanted to create a new column that's called, let's call it the midpoint, or the average, and add it to our data frame. So the way that we do this, a data frame works in bracket notation. So we'll say df, and we'll do brackets and call this mid. So this is basically us saying in this data frame, create a new column and set it equal to, what we'll do is the data frame column high plus df low. So the sum of these two divided by 2. Go ahead and hit this. All right. So now if we open up a new cell, type df, we could see that we have that average value. And so this applies your logic across every row. And so when you create a new column on a data frame, you can do something like this. Now, this is a good example. This is just like a basic average, obviously. So in the previous lesson, we learned about defining functions. So another cool thing that you can do is you can actually write a function and apply it to a whole data frame. So we can do that by, if you recall from lesson 1, typing def. We'll call this function average. It's going to take two variables or two arguments, a and b. We'll end the function definition with a colon and hit enter into the body. And so what we're going to want to do is return the value of a plus b divided by 2. All right, so we have our function defined. And now let's say we wanted to apply an average between two numbers across every row. So we can do that in a special way. It's called a lambda. It's a function that is basically applied across a data frame. And so we'll create a new column and apply this function to the data frame. So I'm going to create a new column on our data frame called df. I'm just going to call it new mid, just so you can see that the output becomes the same, but the way you apply it is a bit different. So we're going to type data frame apply. We're going to type the keyword lambda, a variable x, and a colon. So now we've got our function that we want to apply. Now we want to write the logic for what the function is going to do. So I've got a function that we've written called average, and it takes two arguments. So the arguments that we want to pass on the data frame are, we can do the high is 1, and then x low is the next. And there's one small piece that you need to add in here. It's called axis equals 1. So this is basically telling the function to apply it across the row instead of the columns. And so when we run this, when we print our data frame, you can see that our average, this function is essentially doing the same thing. There's just different ways to apply this. Nothing's right, nothing's wrong, but just kind of highlighting that if you have code that you want to replicate, if you want to write a function, make code a bit more consumable, you can do things and apply things in this manner. So a couple of other things that are really nice, especially as you're working with time series data, is that Pandas comes out of the box with a lot of great time series tools. So for example, it's pretty common that you'd want to do some moving averages across a data set like this. So if we did a simple moving average of the daily high, we can do this. We'll create a new column, call it simple moving average 10. And what we're going to do is we want to take the simple moving average of open. Now Pandas has special keywords that does some of the complex stuff behind the scenes for you. So you can just type dot rolling, and within rolling we want to tell it the rolling window that we want to do. So let's do 10, and we want a 10-day rolling average. So now by hitting, again, we run this command, we'll open up a new cell and we'll look at our data frame. You can see that we have a 10-day moving average applied to our data frame. So let's just look at the last 20 records here so you can see kind of what the data frame looks like on a whole. So here's our 10-day moving average. I'm going to go ahead and delete this. So, I mean, we can do the same thing again and open up the range to a 30-day average. So if you want to do comparisons of different timelines or different time horizons, it makes it really easy out of the box to do. Now, a lot of the things that I'm showing you are just scratching the surface of what these tools can do, but I want to set it up in a way where you can consume some data, rerun and replicate some of this code, and then take it and make it your own. So let's just run the 30-day average, and so you can see what the 30-day moving average is compared to the 10. One other thing that's nice is, let's say you wanted to do some daily price change analysis. and I wanted to know what today's price is versus the previous day. So they have other cool key functions in here. So I'm going to call this one previous day open. So I'm creating a new column called previous day open, and I want to set it equal to the value of the data frame for the value open. I'm going to type .shift1. So I'm going to basically in this column, I'm going to look at what the previous one was and hit enter. So now create a new cell, take a look at what our data frame is. And so you can see our previous day's open, which is 2,516, is our previous day open here. So you can see now if I want to do some comparisons of today's open versus yesterday's, you can do some cool things like that. And so all of this comes out of the box in Pandas, and it's relatively simple and well documented to use. So one small last thing is they have some pretty basic plotting capabilities in Pandas. So with this one library, you can do a lot of really powerful stuff, and there's a lot more that you can do. But again, this is just to kind of get you familiar with the tools that are used in this type of analysis. So I'm going to show you a quick plotting example. So let's just plot the close versus the moving averages that we created. So I'm going to type df, and in double brackets on the inside, I'm going to write all the columns that I want to plot. So I'm going to type close, comma, SMA 10, comma, SMA 30. And then at the end of this, I'm just going to type the keyword plot, close parentheses, and hit it. Cool. So now you can see the Ethereum simple moving average, the close price for 10 and 30 days. And you basically created your first full kind of analysis of some market data. So in the next lesson, what we're going to do is actually go through a little bit more complex charting packages. So there's a lot more that you can do on the charting side of the world. And again, each of these packages are extremely popular, well documented. I'll provide you some links to resources that I find interesting and useful. But also, this is meant to get you up and running quickly, familiar with some of the core concepts. So just to reiterate, what we did is we installed Pandas, we imported it into our notebook so we can use it. We created a data frame here by importing a CSV file. We added our own columns, we did some data manipulation, and we ended up plotting it. So again, really, some core fundamental work here, but this is the foundation for which you can build some really strong and complex analysis. So in the next lesson, as I mentioned, we'll go through some more complex charting, and then finally we'll wrap up with consuming data directly from the GVol API, the Deribit API, and some other resources, and we'll do some more complex options analysis. But again, just getting everybody up to speed on some of the basics. So thanks for joining. If you guys have any questions, feel free to reach out to us. We're always active answering questions on Twitter @GenesisVol. You can find us there, obviously on YouTube as well. So thanks for listening, and we'll catch you next time.